All right, any questions about that one? I need to get me some water. All right, so we okay on that one? And then I heard somebody on this one said 3 times -4. That's the place to start. So that's -12. All right, so those top and bottom, they're both the same sign. So we're adding them essentially. If you want to, you can look at it like this. That's what it means. So -32, right? And what about the denominator? That's -4. -8. And then 2 negatives, so this is going to be a positive. 32 divided by 8 is 4, right? All right, any questions on that one? If you think you don't understand something, or if you think I did something wrong, let me know. All right, so what are we going to do here? See, we got some values up there, and they tell us that x is -2, y is 1, z is equal to -4. So this a, the first one, we're going to use what?
-2.
That's a z, isn't it? Is that set up right?
Yes.
So, yeah, that's the z, and the whole thing is squared. So 3 times
16.
is 48, right? Questions on that one? All right, what's coming on with this one? Did anybody got an answer on it yet? Okay, this time we're going to use -2 here
Add -1 for that one.
in the denominator, right? So it's y is 1, so it's 1, -3. And very similar to that one up here, we do the multiplication first. So -10 plus 12, take the difference, which is 2. 1 take away 3 is -2. So what do we got?
-1.
Good. Any questions about those? All right. Now we're getting into some expressions that we want to simplify. And this is just, collecting like terms. These and these two. 8x plus 2x.
10x.
Good, yep. And then -4 and a positive 1.
-3.
Good. So that's all there is to that one. The next one, we got to distribute some. Well, we got to distribute twice. So it's going to be -3 times 2x is -6x. -3 times -5 is +15, right?
Yep.
And then here, 5 times 2x is equal to 10x. Good.
Plus
5.
Yeah, 5 times 1 is +5. And then we're going to combine those two and these two. So -6x plus 10x is 4x, right?
Yes.
15 plus 5 is 20.
20. So it's 4x.
So that's all we can do, right?
Mm-hmm.
All right, page 2. All right. So these are going to be just equations using that same kind of principles, collecting the like terms if possible, and then if not, collecting across the equal sign where you'd have to do the opposite. And then once everything is of variables, term on one side and number on the other side, then you divide by that number in front of the x. In some of these, I mean, I'm used to, for the most part, is I would put my x is on the left and my numbers on the right, and that's always fine, but you don't have to do that. If you can understand it like this is fine. This essentially means the same thing as this, if you want to turn it around. All right, does that look good?
Yes.
All right, we'll go on to that second one. Somebody tell me when they get it.
It's 5.
Yeah, this is just a one stepper, right? So it's -20 divided by -4, +5. Go on. They're going to get a little bit more complicated with the things you have to do.
For C, I got -2.
All right. Anybody else want to second that?
I got the same.
All right. Let's see then. All right. So I'm on a plus 8x. And then both sides by 12. All right. So somebody do D. I want to hear a couple of people.
For D, let me sure I got the right phrase. Is it real numbers? Like
No, but it's all real
yeah,
numbers.
yeah,
Yeah.
all real numbers.
All real number solutions. And why?
Because they equal
Because
the
they're
same thing.
equal.
Yeah,
No matter what you do,
they're equal the same thing.
you're going to get a true statement, but you're going to lose your x's and you'll even use numbers, but it'll still be true. See, when you try to, I'll tell you what, I'm going to do the numbers first. So if you subtract the numbers, both the numbers go away and you got 4x. Now you got enough information at that point. So see, now we got a true statement. Now, if you don't notice that and you try to isolate, you're going to end up with 0 is equal to 0. All right. If we had taken the step earlier up here, we would have had 24 is equal to 24. All right. So the answer to this, all real numbers, number solutions. So you could just try it if you wanted to. Pick any number out of your head, put it in for X, you will get a true statement. All right, move on down. Second set.
For that,
What's that?
for that one, I get x equal 3.
3.
Yes.
I got 3.
All right. So we got to put these together. All right, so now we just pick a side. I'm gonna get rid of that x and then take that part here. So that's gonna be 3 x minus well, it's just 3x. Sorry. All right, what about f?
I got x equals 2.
All right, let's put some of these things together. Here, there's just numbers that need to be put together. We can put together these and we can put together these. So negative 7x. So this is that 19? Negative 49 and plus 68.
You're right, it's 19.
And it's plus 19. And over here it's 2x minus 9x. I must not have worked it. I mean, I had a earlier 097. I must have skipped this one. Because this is the counterpart to this one. I don't remember talking about it today. Because what's going to happen? You try to add the x's together. Both sides, they drop out.
Does it mean it's undefined?
No, it's not undefined.
It's a false statement?
Well, it's a false statement, which means, see, a true statement.
Mr. Cruz. Mr. Cruz,
What's up?
I have a question. Because I thought it would have been undefined. What is the difference between undefined and no solution?
Well, undefined means that we don't know how to do this. In other words, if you're talking about the prime example of undefined is the like anything that's divided by 0. There's no definition for that. In other words, we have no way to figure out what that means. So that's what it means, undefined. It's not an equation. That's just division. Division by 0 is undefined. But for this, it means there is no solution. Cause what that means, essentially means, nothing we put in there is going to make that true. It's always a false statement. All right, I'm going to do the roll. Is Bria out there? She's the only one I haven't seen. Okay. So try these next two. Now I'll just tell you, on one of these, on both of these, there's an easier way to do it, and my way on this one is just multiply by 10, which is the same as moving everything one decimal place, and then you can have 13x see that once you make that adjustment to every one of the terms, because that's what's keeping it to be the same equation, is because you're multiplying everything by the same term, 10. And so that eliminates all those decimal points, and it allows us to just work with that equation there, and it's a lot easier to do with that rather than decimals. But if you don't mind working in the decimals, be my guest. You don't have to do this. So that means 4x
Negative 13.
let's see, 4x is equal to negative 52. All right, yeah, negative 13, because 4 goes into negative 52 negative 13 times. Now, on this one, again, you can work with the fractions if you like. But if you figure out what the LCD is and of all of these, in other words, this is a 1 down here. So you're basically just looking at these two.
For
The,
that one,
the LCD is what?
9.
Yeah.
9.
And if you multiply everything by 9, you'll have no more fractions.
Okay.
Because remember, it's 9 over 1.
For that one, the answer I got is x equals negative 1.
Let's see what happens. You might have got it. All right, so that's just going to be 15 there. So 9x plus 15. And over here, 3 goes into 9 3 times and into itself once. So that's 6. 3 times 2 is 6x. So 3x is equal to
I
negative.
also got -1.
I don't think this is -1.
I got -5.
Yeah, it's -5. All right. Any questions about that? Just look at them for a minute. If you got any questions, let me know.
Mr. Cruz, how you got -5?
-5 by 3.
Yeah.
I mean, if you like, at what point? I mean, right here, it's pretty obvious. -5 divided by 3. But if you're talking
Yeah.
about up here, how did I get to that point?
No. Okay. So I did everything that you did, but then I
Mhm.
got after I subtracted 6 on both sides first, and it gave me
That's
-3.
fine.
So I did 3x plus 15 equals -13. I did 15. I subtracted 15 on both sides, and that gave me -28.
All right, let's see if I got enough room to do that here. All right, so you said you subtracted 6x from both sides, or you did 9x? Which way did you go?
6x.
You subtracted 6x, right?
Yes.
So that gives you here, they're gone. And then when you subtract 6x here, you got 3x.
Yes.
Okay, what about over here? What did you get on the number side? There was a positive 15 over here. So
Uh-huh.
when you subtract from both sides, that's -15. What number did you have? You said you had 28. How did you get the 28? What were you?
Because I think I had did 15 because I got 3x after I subtracted the 6x. I did 3x. I got 3x plus 15 equals -13. And I thought we were supposed to subtract 15 on both sides. So I did -13 and subtract 15.
Well, I did. Subtract 15 here. So it's gone. Over here on the right-hand side, there's no other numbers over there. So it's just -15. See what I'm saying?
Yeah.
There's nothing to combine that number with. That's the only number in the whole equation.
No, I thought because right here where you got your mouse at, I thought that was 13. I didn't know that was -1. Oh, it's
Well, you said 15, right? -15.
yeah.
It's
I don't
negative
know my
15.
fault. I thought that was 13. My fault.
Yeah, -15. It just like a poorly written 5. right, let's go down to the. Okay, so this is it. So now we got wordy stuff. All right. So this is one of those equations we got to set up from the words. Okay, 4 times the difference. You remember what difference means?
Subtract.
All right. So 4 times and since it's a difference, that means there's 2 things. So that we got to have a parentheses. A number and 1. A number is x
-1.
minus 1. That's the difference part. Is equal to.
And let's see if I have two of these. Oh my Lord, I don't know why I put two of this stuff down there.
You looking for?
I don't know.
You pad on?
Yeah, I'm gonna try to find me a blue.
I don't got nothing in my room. Sure.
All right, somebody's audio is coming through and I can't tell who it is.
Oh, that's mine. I'm sorry.
All right, so now on this side is equal to 6 times the number and 8. Because it's sum of, and it's not like this where we had 4 times the difference. This says the sum of 6 times a number and 8. All right, any questions about that? All right, so we're going to solve it. And we got a distribution to do. How would I keep writing 8s instead of X's? I must have like fried the part of my brain that understands X's. Keep putting some other thing instead. All right.
So you only put it in parentheses when it's different, when you're subtracting?
No, because if it says 4 times the sum, you would do the same thing. You'd put it in parentheses. See, this is a sum, but it says the sum of 6 times a number and 8. You're not multiplying anything times that sum. If it had said here is equal to 4 times the sum of 6 times a number and 8, then yes. But there's nothing here indicating that you're multiplying the sum. This says 4 times the difference. And what is that difference? It's a number and 1. If it had said 4 times the sum of a number and 1, it would be x plus 1 times 4. All right, and however when you want to work it, I'm going to just work it real quick by doing the 2x. So that's what am I doing? It's supposed to be negative 6x. This should be an equal sign.
I got -6.
As soon as I say. Now, yeah, you're right. Because of that -2. Because it's 2x equal to 12 or -2x. And then when we divide by the -2, x is equal to -6. All right, any questions about that one?
Bruce. Ask another word problem that was similar to this one that I saw on the practice test. It was a simple one. It just said subtract -4 from -1.
All
And
right, let me subtract
yeah, it said
-4
from -1.
So -1, take away -4.
It was negative. Well, it said the answer was 3, but I came up with -5. Am I doing that wrong?
Okay, read it out again.
It says subtract -4 from -1.
That should be -5.
Yeah, and when I double checked the test, it said that the answer was 3.
Which test was that?
I believe it was the last one before it was the last practice quiz.
The one that says practice test?
Yeah, I believe so.
All right, who's talking to me?
Nicole.
Who?
Nicole?
Okay. I'm going to look in.
Because I went back, I was like, maybe I'm doing something wrong, but even if you write it the other way, -4 minus -1 is
Yeah,
still
either way.
-5.
Okay, this is V71, isn't it? This is the even section. Oh, so right at the first. I don't know where I'm at. Yes, it is. After we do that, number 6, I'm going to take a little break. All right. You remember where it was at? Was it the first one or was it 12, 13, 21, 23? Let's see. Not that one. Not that one. Oh, okay. Gosh, boy, I'm crazy.
You found it?
Yeah, I found it. I'm just crazy. It's subtract -4.
Yeah.
See that? We're subtracting -4. So what does that do? See that?
Let me see.
Subtracting the -4. So that's the negative, which ends up meaning you add it.
Okay.
I don't know. When you said it, I thought I heard it as subtract 4 from -1. But it's
This right here
subtract
was,
-4 from -1. You might have said it exactly as
no, it's
written.
that's why I was saying it says subtract -4 from -1, but in my head I was thinking the same way as you, which is,
Yeah. Well,
-1 minus
just
4.
remember that's the common mistake when you subtract a negative number, you end up adding it.
Okay.
So one of the negative signs essentially is the word subtract. So that's why this happens.
Okay.
All right. All right. I recommend with these to if you do a little thing, little diagram. Let's see if I can. I'm trying to do it so we can save room to work. So this right here is 12, okay? That's 12. Now we got a 12-foot board is cut into two pieces so that the longer piece is 8 feet longer than 3 times the shorter piece. Well, generally speaking, your shorter piece is X. All right. Most of the time you want to make your smallest piece X. There are some exceptions, but I've not seen any in your work. But sometimes it just might be better off to use X for the larger one, but not in anything that I see so, so far. Okay, that's a cut right there. Now, they told us that the longer piece is 8 feet longer than 3 times the shorter piece. So 8 plus 3 times the shorter piece. See that? 2 pieces, X, and then the other piece is just 8 feet more than 3 times. So that's the equation. Is equal to 12. There's the equation. The way that it's set up, it's not simplified yet. It's just, that's the way it's set up. Questions about that? All right. So the shorter piece, well, we got to solve this equation. So I'm going to combine the x's. So that means 4x plus 8 is equal to 12. So x is equal to what? So how can we find the longer piece? How do you find that longer one?
Right. Got to plug in 8.
Okay, we know that, right? So how can we find out? Since x is equal to 1, then we're going to just put in here 8 plus 3 times 1 in place of the x. So it's 11 feet. And see, you can tell that's right because 11 and 1 is 12. All right, let's take a little break. As I said, I'm about shot here. If you got any questions, just, you know, type them in the chat or bring when I get back.
I cannot hear.
Mr. Cruz, I can't hear you.
All right. All right. Can y'all hear me?
Yes.
Yeah.
Okay. I don't know what's going on. I was actually trying to change because this microphone, I mean, this camera I got it's got a mic in it. And I was trying to just turn to that rather than having to wear these silly headphones, but because I can hear everybody just fine through the speakers on the computer. So I don't know why it didn't work, because it was working and then it stopped working. Okay. Hopefully by Wednesday, I'm going to get that straightened out. I'm tired of wearing these things. All right. So this one is just a substitution problem. See, they give you these two pieces of information. So just plug it in. That means the P is 22. We don't know what L is, and that's what we're going to solve for. And then we got 2 times W, which is 2. So I hate when they use these L's, but I guess you really have to for perimeter. All right, so 4 over here, 2L. All right, any questions about that one? Can you hear me okay?
Yes, I do.
Okay, good. I don't know what happened a minute ago. Oh, wait a second. right. So any questions on that number 7?
No.
All right. So now the next one. These are solving. I'm going to add a C here because these are really more important. These time, and maybe I'll even use a D. These are more important than those types because you're going to be doing this in the rest of the semester. I mean, it's somewhere in the semester. Solving for Y on these things. These things, I mean, the only, there's not a whole lot of reason to do them for, I don't personally believe. I mean, it's good to be able to know how to solve for a variable, sure, but in this context is the most important way. All right, now on this one, how would you get started on this? You're going to solve for B, which is right there.
Want to multiply by the reciprocal.
All right, and the reciprocal of 1/2 is 2 or 2 over 1. So 2 times A. And then when you got 2 over 1 times 1/2, see how that's going to just make it 1. So 1BH. We're solving for B. So we got to get rid of the H. It's multiplying, so we're dividing. So B is equal to 2AH. All right, so on B, there's an extra step. Okay, we're solving for T, which is right here. But before we can deal with that, we got to deal with this thing.
Mhm.
So that's just basically going to be A minus P is equal to P R T. So on this side, P R, and then these are gone. So it ends up being T is equal to A minus P R. So that's solved. Both of those are solved. Now, what I want y'all to do is try to work on these and see if you can solve for Y. This is for both of these for Y. Okay, so what can we do for this first one? Or if you got anybody got a solution? Yeah. Y is equal to something.
Y is equal to 4 minus 2x.
Okay, let's see. So the first thing we need to do is get rid of the 4x. It's added, so we want to get rid of that rascal. And then we got 2y is equal to 8 minus 4x. And then we're going to divide by 2. And everything gets divided by 2. So y is equal to 4 minus 2x. Great. Now, just remember, I mean, this is fine. I'd be real happy if you got to that. But when we get to this, they usually will turn it around like this to be in the slope intersect form. You may remember hearing this. It's y is equal to mx plus b. -2 is the m, and 4 is the b. And if it's in that form, it's just a little bit easier to spot. But these two, they mean the same thing. Try that second one.
We're still solving for y, correct?
Yep. Anytime you got those, what we call those that are in standard form, x and a y is equal to something, you know, there's no point ever to solve it for x. I mean, there might be one purpose, and and that's we could figure out. But generally, if they're in this form, you want to solve them for y. And then sometimes if they're solving for y, you want to come back to this. But we're not doing that yet. That'll be towards the end of the semester, I think. When we
Mr.
do that.
Cruz,
Mm-hmm.
how you got -2x plus 4?
8 divided by 2 is 4. -4 divided by 2 is -2. Right?
Oh,
And then I just turned it around because, as I explained, there's something called the slope intercept form, and it's y is equal to mx plus b. So if it's in this order, in other words, if the x term comes first, then this is your slope, and that's your y-intercept. And I think we hit on it a little bit in chapter 3, and then we get a little bit more to it later after midterm, towards the end of the course. But that's the reason why I gave you these extra ones is because these are far more important than dealing with these.
Okay, yeah, because I'm a little kind of lost on that.
Okay. Well, let me ask you a question then.
Okay.
We want to solve for y.
Mm-hmm.
So when we got something added, you treat it just like you're solving for a variable, and you kind of treat this as a number, even though it's not going to combine over there. So this thing is added to 3y, so we got to get rid of it. So we do what?
Subtract 6x.
Yeah. And we do it here to get rid of it, and we do it over here because that's where it's going to live at.
Okay.
So now we got 3y is equal to -6x plus 9. That's the plus 9 right there. -6. I just turned them around.
Okay. Okay.
Now divide everything by 3
Okay.
to get regular y.
Okay.
And what is that? Y is equal to -2x plus 3.
Okay.
Yeah. So as far as solving for formulas, you may have to do that one of these type on the test. But like I said, these are the ones that are important. These ones with the X's and the Y's. Because we're going to be doing that later. And that's why you're learning it here.
Okay.
Okay, any questions?
Yeah, well, you don't mind giving us another problem like that?
Well, let's see if I can find someplace to put it.
Okay.
Tell you what, I can put it on, I can do the share on the board.
Okay.
You're just going to have to remind me to go back to that other thing. So let's see. I'm not sure how even this will come out, but let's try it. And then we want to solve Can you see that?
Yes.
Okay. So 5x plus 10y is equal to 25. Solve
Mhm.
for y.
You gotta subtract 5x, right?
Yeah, good. Yep.
From both sides. So when writing it, it's gonna be 10y minus, 10y equals, is it negative 5x, or do you write 25 first?
It doesn't matter. I would recommend, though, putting the negative 5x first
Okay.
just for later, because there's something called y is equal to mx plus b.
Okay, gotcha.
And then if you got the x term first, once we solve now for 10, go ahead and tell me what happens when you divide by 10.
You gonna have y equals negative 2x.
That's not 2, I don't think. That's you're doing it upside down. Unless I'm
Oh,
crazy.
yeah. Um,
5 over 10
is it 1/5? No, wait, no. Yeah,
5 goes into 10 how many times?
2, 1/2.
And this, all you can do is just simplify it down to 5 halves.
Oh,
But see, that's the y is equal to mx, so the slope is negative 1/2, and then the y-intercept is 2.5. Let's see if
okay.
I can come up with a better one. You're gonna probably and occasionally have one that's got a fraction here, but
Okay.
I didn't want y'all to be worrying about that now. Let's see if I can think of something. So try that one. 6x plus
Okay.
4y is equal to 24.
Okay. Right. Um, is the 24/4 gonna be a fraction, or is that gonna equal to 6?
Yeah,
Yeah,
if it goes
6.
down. This one's not, but that's often the case with this one because that one can be a fraction.
That's gonna be -4/2, right?
So y is equal to
-4/2.
plus 6
X.
here.
Mhm.
What is that? The only thing you can do, no, well, yeah, they're both divisible by 2. So that's 2 goes into 6 3 times and into 4 twice.
Oh, I did it wrong. Okay. Yeah.
But these by far are the most important ones to take out of this chapter, is being able to solve for these XY ones, because we're going to be doing that a good bit later on. Because like I said, that can be very helpful for graphing things.
And y equals 6.
y is equal to negative 3/2 x plus 6.
Okay.
Like I said, it's
Mr. Cruz, I have a question. And instead of put a fraction, can we put decimals?
You
For
can.
example.
You can, but as I have said many times, this is algebra. Generally speaking, fractions, improper fractions are going to be more helpful. Because let me tell you, but let me just write this out.
Mm-hmm.
Because if you have this, I mean, I don't know how much math you have.
Yeah, is that 1.5, negative
See
1.5?
this? What is the slope then of this line? It's negative 1.5. It's a little bit easier to do this because there's something called rise over what?
Run.
Yeah, rise over run. And that's equal to negative 3/2. I mean, if you put it like that, you just got to remember that this is what it is. Like I said, generally speaking, in algebra, mixed numbers are of very little use. The only thing they're good for is determining how, where their place is on a number line. I mean, when you had 7th grade math, you probably done a ton of these where you had to change back and forth or something like that. But generally speaking, in algebra, this is a lot more useful because this tells you how many to rise, and then that tells you how many to run. We're not doing that yet, but I'm just telling you. That's what the purpose of it is. And when you do multiplying, oftentimes, if you multiply if you got a fraction, like I said, is here, if you wanted to convert this back to this right here, which is going to happen later, you multiply everything by 2,
So,
and then you lose your fractions.
so basically what you did is that basically you simplify the fraction that you had on the top, that it was like 6, half of 6 is 3, and for 4, half of 4 is 2. That's what you did?
That's all it is. Yep.
Oh,
That's
I
all you
didn't
can
understand.
do. That's all
Oh,
you can do when you work it in that situation where the fraction doesn't whittle down to a whole number.
oh, okay.
You just take out the largest common multiple, and that's it.
Okay, great.
All right, let's see if we can go back to and share that other thing. All right, so we got another page here. So I think we only got one more problem. All right, yeah, it's those percent things. Why don't y'all try those? Since that's should be pretty fresh on your head, and then
Mr. Kirk, I have another question, but this one is a little bit random. For the exam, can we use a calculator, the one that you
can.
told us to use?
The one on the syllabus, yes, you can.
Okay, thank you.
You just declare it at the beginning, show what you got. Yeah. If you want to use that calculator, the one that's on that syllabus addendum, you're free to use it, and you can use it for a couple of semesters if you're Delgado, because they use that in 120 and 130. So and then another class too. I don't know which one, but that's a good one. And it only costs about $10. But in my math lab, they do have a calculator. If you want to use that, I mean, that's all you can, free to use that. All right. So anybody come up with a
For A, I got 63.
I got
all right. So I'm going to write it out. So what number, as our variable, is 70%? We got to do it as a decimal of
63.
90. X is equal to 63. And then we can state it sort of like this. I like to do this just to make sure that it makes sense. 63 is 70% of 90. And that makes sense because you can also, I got this crazy calculator, but if you take 63 and put it over 90, you'll get 70%. Or 0.7, 7 decimal, 0.7, which is 70%. So what about this next one?
Got 90.
All right, so 54 is equals. You gotta put that as a decimal. And they don't have on here the third type, which is the one where you don't know the percent.
Is it 32?
So, let's see. All right, so I'm going to rewrite this. Write the right way backwards. Actually, it was written backwards. And so now, divide both sides by 0.6. So X is equal to what? 90. So 54 is 60% of All right. Any questions about those?
Yeah, how you got that again, Mr. Cruz?
How do I get it? Which part?
How you got 90? Because I got 32.
54 divided by 0.6 is what?
Oh, divide. Okay.
What were you doing? Multiplying it times?
Yeah.
Yeah. I mean, that's why you got to set them up right. I mean.
Okay, gotcha.
Can we do one where we get the percent?
Okay, let's see if I can make something else up for you. Shouldn't be too hard. All right, let's see. Let me do it like this. So give that one a try.
75%.
Okay, let's see.
I got that too.
So 90 is x times 120. And I like to turn it around. So that's 120 x is equal to 90. And then it can go down one more time because they're both divisible by 3. They were knocked off the zeros because that means divisible by 10. So 3/4, which is boy, I just made that up and it came out to a nice even one. So that's 75%. All right, so that means all right. Now that's the last problem on that review sheet. If you want me to stick around here, I'll be glad to. You're just going to have to tell me what you want to know because I would much rather do that any day. Because like I said, there's only so much I can go through. And I think that review is pretty comprehensive.
Get a little documents on your door.
Mr. Cruz, we got that proper use set up for the test, right?
No, not for this one. What I want to do is I'm going to let you do we'll do a dry run on the second test. Because on the midterm, we have to use it. So this one is just a regular test. So just a regular test, it's just like your quizzes and everything else you take, and you can take it without any thing. And then, like I said, is the next test will have that.
Okay.
Professor Cruz,
Mm-hmm.
this is Trinice. We can use our own calculators, or do we have to use the ones with my
Well,
math?
here's the thing is, okay, this is the one you're supposed to use. If you could use the one in My Math Lab if you want to and not have to buy a calculator. If you buy a calculator, I mean, most of the math classes at Delgado that you would take, you're going to have this calculator.
Mm-hmm.
The one over here, and this is the one you should use. I mean, I'm not got no way to. I'm not going to be enforcing it on this first test, but this is what you're supposed to have. So if I end up, dead halfway during the semester, you got no right to complain if another teacher comes in here and says, "Hey, you're using the wrong calculator," because everybody's got a little bit different philosophy about it. This is the rules. I hate enforcing rules unless I think they're important, but this is the one you should be using.
Which one is that? I have the T130XS.
Well, let me go down and point it to you. This is in here. It's got a real long name, and I have to go look it up every time. Wait, I got the wrong share. I have to always come back over here and look at it because it's got a funny name. To me, the calculator business is crazy. It's just to keep TI in business. It's like textbooks and all that. All right. So where's it at? I think it's up here.
I think I did see this one in the syllabus. It uses
Yeah.
that either that or how.
There it is right there.
There it is. Mhm.
I don't know why everything's moving so slow. There it is.
Yeah. So
TI 30 X2S.
Mhm.
And then if you want to see what it looks like. Because the thing was, I got in trouble one time. I mean, it's a long story, but somebody had to proctor one of my students on an exam.
Mhm.
And they had told me, oh, well, the teacher that I had before, when I took this class before, said I could use this one. And it looked pretty darn close to me. I mean,
Yeah.
and then he went, where this teacher that proctored, you know, she jumped all over the kid and on me and let him one like this. Okay. Because evidently they do different things. And
Mhm.
I think they don't want you using one that does all the work for you for certain things. That's the only thing I can think. I mean, now that's right there is more expensive, but this is, like I said, it was, I mean, it says here Walmart's got it for $8. Let's see. Walmart's usually the cheapest price. Oh, why did I get that? It said $8 when I clicked on it. What,
Yeah.
what did they all of a sudden start filling them with gold? Let's see. I can say this: they were $10, and now here's one that says Walmart 13. So
Yeah, it's actually $13. I work at Walmart.
Walmart is like usually the best price. So
Yeah.
that's it right there. So if you
Mhm.
got that one, like I said, is. But if you got for this test, I'm not going to ask you to go out and get a new one. Just